In this lesson we're going to talk about logarithms, natural logarithms, how they work. Then I will provide about 6 formulas to understand them, and then I will also talk about some formulas that aren't in the formula booklet as well. And then we're going to top it all off with an exam question to make sure you understand the topic as well. So the main formula of logarithms is the following. Log A of B equals C, and B is equal to A over C. But they are an opposite to an exponential power. So let's bring out an example here that we have log 10 of 100. So essentially what this means is that if we put 10 here, the 10 can go here, and we want to know that how many powers does it have to be. Let me take another color. How many powers does it have to be 100? And in this case you mostly start to understand that of course x is 2, and therefore you can conclude that log 10 100 is equal to 2. So essentially what you want to get is the power that turns your base is this, into the number provided, and the number provided is this. So let's bring out another example as well. I think it could be more beneficial. Let me change the color. So log 2 is, and let's put here 64, and you want to get the answer. Of course you can plug it into your calculator, but in order to get actually good points on your IB exams, you want to understand how the logarithm machine per se works. So you can put it here. You can imagine that it's 2 to the power of what? What is the power of 2? 2 is always the base. The base goes here. You take the base, you put it here. And then you put it to the power of x. And you want to know, what does x have to be? To what power does 2 have to be equal to 64? And you can always check this, and I think I already know it by heart, that if we put 2 to the power of 6, it's 64. And then we get that the answer is 6. And you don't always need to know this, because you have it in your calculator as well. You have to go to math, you go to straight to the bottom, and there's log base. So the base is your first one. You can choose whatever. Let's do our same example. Log base 2, and the number is 64, and we get 6. And sometimes in questions you also see without the base. If there's no base, for example, your question has just log 100, then if there's no base provided, for example like here or here, then the base is automatically 10. That's the rule. And that almost concludes it. And most of you are also figuring what are natural logarithms. So most of you know, or if you haven't now, we have the Euler's number E. And E can be typed on your calculator as well, and to get the value of it you can put second and the division symbol, you get E. And E is roughly worth about 2.71 and etc. And natural logarithm, which you will see is like this, is just equal to log, and the base, if the base in this case is 10, in this case is 2, here is also 10, then in this case it's very simple to just understand that natural logarithm is the exact same as log, and the base is e, also known as 2.71. So now let's also cover some formulas that you have to know. So the 3 most basic formulas that you have to know are also provided in your formula booklet. And the first formula is the most necessary because it's very evident in some exercises in paper 2, where you have to do and you have to notice the pattern. So you have to understand that if 2 to the power of x is b, then you can also rewrite this as x is equal to log a b. And in many cases you just have to notice this. And for example, in many exercises it said that you have to get the logarithm out of here, and you have a function that is y is equal to log let me put 4x, and then you have to get it into a normal function, and it said that to remove the logarithm from the function, then you know from your formula that you can just rewrite it as x is equal to 4 to the power of y. Yeah. And the 3 other formulas that are also given, which are not as important, are also given in the next one section. It's called 1.9, the laws of logarithms. And I wouldn't even write them down, the first 2. I would just try to remember them, as in most cases you won't need them. However, the last formula, log, let me write it down with numbers as well, log a x m is equal to m log a x. And this is also very superficial, because if you see an m here, and in some cases, most cases that you have to do all of this is when you're dealing with logarithmic functions, and you have to simple it down to a better formula, and then you can clearly see that that if the x is powered to the m, you can always bring out the m to the front, and you can rewrite it down. So let's say that you have like y is equal to log 2 to the x power of 4, then you can always rewrite it as y is equal to log 2x. And here you can also notice a pattern that you can use this formula as well, and you can write it down as even simpler, and you can keep on going. So there are still some formulas that aren't given in your formula booklet, and I want you to remember them as well, because in exams you really don't have time to start figuring out all of this. So the first one is quite easy. When you have something of logarithm and here is 1, it's always equal to 0. And if the base, I think this is very understandable, if you have log 100 and here is also 100, then you know that 100 to the power of 1 is equal to 100. So obviously it's 1. This is something new, but this is also very important. If you have a log a m, you can always bring out just the m and get it that everything is equal to m. You can just understand that they all cancel off except m. And the same case is for e, because e is the same as log e m, and if your base is the same as the number in the power, then you can also write this down as m. And that should be all that you should know about the formulas when you're going to do your paper 1 or paper 2, or even maybe paper 3, depending on the situation. So let's end this with an exam question to make sure that you actually understand the topic. The loudness of a sound L measured in decibels is determined by the intensity of the sound E, measured in watts per square meter. The relationship between loudness and intensity can be expressed using the logarithmic function. Great. And where ei0 is the reference intensity, and the reference intensity in this case is 10 to the power of negative 12. The intensity of a sound on a busy street is 10 to the power of minus 5. So of course the A is always the easiest one. You just calculate everything that you're given. You can just press everything straight to your calculator. 10 log base 10. Then we can see that the intensity I0 is 10 to the power of negative 5. The bottom one is 10 to the power of negative 12. And we can conclude that the loudness of the sound is 70 for A. In this case it's in decibels. It's important to write them down as well. These type of exercises are actually very common in your paper 1, and where the first part is simpler, however the second part requires more thinking. So in this case you're given the sound of a jet engine reaches a loudness of 185, so you're already given that L is equal to 185. However, now you need to determine. So we also know the intensity of the reference intensity, and that's 10 to the power of negative 12. And you can always go to numerical solver, and I always recommend to use numerical solver when you know that there is going to be one certain answer. If you start to think about it, in some cases like functions, quadratic functions, or even cubic functions, there can be 3 or more even answers to your question, so then I don't recommend this. However, in this case we clearly know that the I is one certain answer, therefore we can put that to one side, that 185 is equal to 10 log base 10, and we want to find the intensity, so we can put it as x, and then we can also put our reference intensity, which is 10 to the power of negative 12, and then alpha solve. You get your answer to be 3,000, a very huge number. And then you need to write it down. It says as give your answer in your scientific form, also known as this form. Then you will choose the 3 first numbers, meaning that it's 3.16. And then now we look how many decimal places does it have.